All right, welcome to the first chapter, our first section, applying properties of real numbers. Again, this should be a review of Algebra 1 and a little bit of geometry. So you should have received a set of note-taking guides. And the very first page of the note-taking guide should have this vocabulary right there. And the first one should be opposite. Now, we talked about this in the words to review. The opposite of any number, it's also known as maybe the additive inverse, but instead of using it numbers as an example, it really should say that use a variable. So the opposite of any number b is opposite b. So what that means is this. So the reason you use a variable is because you would say if the number you have a 3, the opposite of that is negative 3. If you had a negative 4, the opposite of that would be negative 4, which is 4. That's what opposite is. Reciprocal. And you really should say that it's any non-zero, that's actually quite important, number b. The reciprocal of b is 1 over b. If you had negative b, the reciprocal would be 1 over negative b. If you had 3, you'd have to think of that as 3 over 1, so the reciprocal is 1 over 3. Now, there are times, and we'll say this, we'll put these two things together, opposite reciprocal. The opposite reciprocal is the opposite sign and the reciprocal. So now, for the opposite reciprocal, you would have b becomes 1 over negative b, because it's the opposite and it's the reciprocal. The real numbers, now we're going to talk about subsets of real numbers. A subset is basically telling you that there are groups within this big group of real numbers. So real numbers are basically any number you can actually, represent, like a decimal or a fraction or whatever. But within that, you can have whole numbers, integers, natural numbers, counting numbers, irrational, rational, a bunch of different kinds. So the real number consists of the rational numbers and the irrational numbers. Two subsets of the rational numbers are whole numbers and integers. There's a whole, I took a whole class, a semester of in college that dealt with the subsets of real numbers. Like you had to be very specific about what it can be. So let's explain some of this. Rational numbers can be written as quotient of integers. So this right here simply means that a rational number can be written as a 1/3 or a 2/4 or a 5/3. It can be just 3, because 3 is just 3 over 1. So it can be written as a quotient of integers. Now you can also think of it as decimals that repeat or terminate. 1/3 is 0.3 repeating. That repeats. 2/4 is 0.5. That terminates. 3 over 1 is 3.0, and it stops. 5/3, I believe, is 1.6, repeating. So if they terminate or repeat, they are called rational. Irrational numbers, on the other hand, cannot be written as the quotient of integers. So they are not, basically not fractions. And they cannot be written as decimals that terminate or repeat. So they aren't, there will be no bar over top of it. There's no way to actually write out these numbers. So instead, what you have to do is you have to assign them, write them out either in their mathematical term or as a symbol. So pi is an irrational number because it goes on forever, it does not terminate, and it doesn't repeat. The square root of 2 is an irrational number. It goes on forever, it doesn't repeat, it just doesn't. So these are irrational numbers. So we're going to graph real numbers on a number line. So first of all, you may have to actually do this division, and looking at them as decimals, even if they're just estimated decimals, will be better. So this right here is negative 2.6. The square root of 6, well, you know that the square root of 6 is between the square root of 4 and the square root of 9, right? So this is approximately going to be 2 point some number. Now I'd say since it's closer to 4 than it is to 9, so it's not 2.5, let's say 2.4. And if you use your calculator, you'll see that we're really close to that. So graph them between negative 3 and negative 2. So this one here will go between negative 3 and negative 2, so about right here. And then do the square root of 6 between 2 and 3. Right there. All right, look at the guided practice. So remember, you're responsible for taking these notes and then completing the guided practice. Now I will do a lot of the guided practice in here. So with this, you're going to do the guided practice on a separate piece of paper. You're gonna have your note-taking guide, and you're gonna have your guided practice on individual assignments. So, number 1, guided practice says to graph these numbers. You're gonna graph negative 0.2, 7/10, negative 1, square root of 2, and negative 4. So you're going to do that on a number line. So you're going to draw a number line, straight as you can. Put a 0 on there. You're going to want to make all of these decimals. 7/10 is an easy one, 0.7. Square root of 2 is a little bit harder. It's basically it's between 1 and 2. Looking at something like that. And now we go ahead and graph them on a line. Let's actually put a scale here. This is all by 1. So the lowest one, negative 4. 1, 2, 3, negative 4. Then the next smallest, negative 1. Negative 0.2. So we've done negative 0.2, we've done negative 1, we've done this. 1.4 or 1.14. Oh, don't forget 0.7. And I think we got it. That's all of them. That's all you got to do for putting these on a number line. All right. Properties of real numbers. I'm not going to, we're going to go over these, and it's good to know, but it's better to know how they work. So this property here, the very first one, this is actually in your textbook under the closure property. A plus B is a real number. So if A and B are real, so it's up here, you see how it says A, B, and C? They're real numbers. That means there are certain operations you can do. And the closure statement just basically says if A and B are real and you add them together, your answer is real. 2 plus 2 is 4. All those numbers are real. 2 times 3 is 6. Everything's a real number. Commutative property just means that when you add, it doesn't matter what order it is. Multiplication, it doesn't matter. 2 times 3 and 3 times 2, it's the same. So one reason that's important to know is because sometimes an equation will be written like 4xy z2. Okay? All this multiplication can be rewritten in different forms. So it could be 4 times 2 times x times y times z, which means it's 8xy z. You can do it in whatever order you want because it's multiplication. The additive, associative property. The associative property says for addition and subtraction, it also doesn't matter which ones you do first. So here, A times B is done first, but for multiplication, it doesn't matter. You could multiply B times C instead. The identity means that you start with a number and you end with that same number. So A plus 0 is A, 0 plus A is A. When you add this number, this right here is the additive identity. This is the multiplicative identity. It just means that you add or subtract something to it and you end up with the original part. The reason that's important, especially with multiplication, is this. If you have 4 over 3x, you can multiply this by 1. And 1 comes in many forms. 1 could be 2 over 2. 1 could be x over x. 1 could be, 3 over 3x over 3x. As long as the numerator is the same as the denominator, then it's just multiplying by 1. So in the future, you may have to multiply by something. I mean, let's just say you want to multiply by 3x over 3x for whatever reason. You could do that. This here is equal to 1. The inverse now is the other way around. It's when does it disappear? What times what gives you the identity? So here's 0. So it's what plus it's basically A plus its opposite gives you the identity. The following properties involve both addition and multiplication. The distributive property tells you that A goes to B, A goes to C. When there's parentheses here, this becomes AB and AC. This is very important because the distributive property works both ways. If you have a 2x minus 2a, in the distributive property you put things inside the parentheses. Here, look at what they have in common. They have a 2 in common. So 2 times x minus a is what you're looking for. All right, so identifying some of the properties. Like I said, we're not going to make a big deal out of this, but let's go over it. So this one right here, see how it's not changing which one comes first. It just changes which thing you use. So this is the associative of multiplication. Here, look, a number plus its opposite gives you the identity. Therefore, this is the inverse property of addition. So, there's a checkpoint. I'm going to do it for you, but you still need to try the guided practice. Let's figure some of this out. 3/4 is 0.75. The square root of 5 is between 4 and 9, so it's going to be 2.2. And now we've estimated it all, and now we can just go about graphing this. -3 halves. -3.2, -2, -1/2, 0.75, 2.2. All right. Let's identify this property here. Look what it did. It took this 10 and put it into the parentheses. There's multiplication and addition. This is the distributive property. All right, let's jump on over to the guided practice. I said I would do some of these for you. Number 3 asks you to identify the property. 2 times 3 times 9 equals 2 times 3 times 9. So looking at, so if you scrolled back to your notes here, and look at these properties, this is dealing with multiplication and the order in which you multiply. So for this one, for number 3, you should be dealing with the associative property. Associative property. Number 7. Number 7 wants you to use properties and definitions of operations to show that the statement is true and justify each step. So here is b times 4 divided by b equals 4. All right. What you're going to want to look at here is the fact that you're using a multiplication, and you're looking at the inverse of it. See this? A and 1 over A. So this problem shows us B times 4 over B, which can be rewritten as 1 over B, 1 over B times 4. So the multiplicative inverse right here tells us that this part here is equal to 1 times 4 equals 4, and so your proof is that you end up with 4 equals 4. Alrighty. Definition of subtraction and division. We're almost done. Defining subtraction. Subtraction is defined as adding opposites. And the opposite or additive inverse of any number b is negative b. So the definition here, so the division is defined as the multiplying by the reciprocal. The reciprocal or inverse of any non-zero number b is 1 over b. So this is just the definition, but basically what you're looking at here is you're trying to just knowing how to undo certain things. How do you undo subtraction and addition? How do you undo division and so on? So by definition of subtraction, 9 plus b minus 9. By the definition of subtraction, this is like adding negative 9. Okay. Then the commutative property says you can rewrite this however you want, in whatever order you want. And then the associative property property says that you can do it again in whatever order you want. The inverse property says that 9 plus its inverse is 0. And then the identity property says that that's how that works. Now, are you going to have to do this step by step in a quiz or a test or anything like that? No. You're going to have to look at this and be like, okay, 9 plus negative 9, this here becomes 0, so B equals B. That's what you're going to have to do. All right, let's look at this checkpoint. Okay, I'm going to do it the way that you should be allowed to do this. All right, 5, A divided by 5. So you would want to rewrite this as A over 5. And then let's just go ahead, and the way we would think about this is that 5 times 1 over 5, or 5 divided by 5, you would say cancels out, but really it becomes 1A equals A equals A, and you got it. All right. So that is pretty much it. You have quite a few more guided practices to do, but we're going to look at something called unit analysis. Okay. And with unit analysis, you have to be able to look at just the units to determine what type of problem, how you're going to solve something. What that means is, if we're going with miles per hour, all right, and you want to find how many miles you went, well, you would multiply by hours because that would cancel you out. So I'm going to do a couple of the guided practice for you so you can kind of see what we're dealing with. Solve problems using unit. This is on page 5. You work 6 hours and earn $69. What is your earning rate? So it's asking you how many dollars per hour did you earn. So looking at the problem, this is number 9. The problem says that you worked 6 hours, and you got paid $69. So that's dollars per hour. Even if I wasn't sure how to do this problem, I would at least be able to know that dollars per hour I could at least match. So 69 divided by 6 is 11.5. So you're making $11.50 per hour. Take a look at number 12. Well, let's do an extra one here, since we didn't do an example. I'll go ahead and do number 10 for you. Number 10 says, how long does it take to travel 180 miles at 40 miles per hour? So what we have here, the information we have is 180 miles, and we have 40 miles per hour. All right. And we want to know how long it takes. So what we need to do is we need to actually divide 180 miles by 40 miles per hour. And what happens here is when you divide by a fraction, you end up multiplying by its reciprocal. So basically 180 divided by 40 gives you 4.5 hours. All right, number 12 now, and we'll do some of these in class. So you need to convert 150 yards to feet. So we need to somehow get to feet. And we get to feet by doing one thing. We need to come up with a conversion factor. And if you're in chemistry, you're going to deal with conversion factors a lot. So 150 yards is in the numerator. We need to cancel out a numerator by putting something in the denominator. Numerator, denominator, they cancel out. And what are we looking for? Well, we want to have feet. So all of you should hopefully think about or look in the back of your book or know that there are 3 feet for every 1 yard. So when we work this out, you should end up with 450 feet. All right, I don't want to take too much more of your time. So this is the practice problem set that we are going to do in class. You don't have to do it at home. If you don't show up to class, you're going to want to work on those problems though. I hope the first or second video or first note-taking guide video went well for you. We will see you soon.